Right, today I wanted to talk about my process in deploying web app proof of concepts. I feel like it's more productive if clients can quickly check out ideas and preview development progress. So recently I've been learning more and more about hosting containerized applications on different platforms. Lately it's been AWS ECS. Anyway, as an engineer who frequently makes web applications, every time I would build something, I want people to be able to quickly try it and get some feedback. But getting it online was a little bit of an effort. Not to mention, context switching between app development and app deployment does take a toll sometimes. So this service makes it easy for me to create an environment where I can build and spin up the image, and I'll be able to get a web application online. I'm sure there are options on other cloud providers. I just know AWS more than the rest. And this does come with some learning curve, which I'll try to make it easy on this video. Okay, so let me pull up a diagram real quick on how our ECS service and other objects we need will look like. So we'll start off with an ECS service. It will always need a task definition. Both of them, they sit on a thing called an ECS cluster. It's just an organized space where services are managed. Meanwhile, task definitions are like Kubernetes pods. And if you're unfamiliar with that, it's basically like a set of instructions for AWS to follow to make your application run, like what type of additional containers it needs and where to get them, how much memory it requires, and what it's allowed to do. We'll also need an ECR. This is where your images or the containers that will be running are stored. You can use other image repository, but for now I prefer a private one, so we'll use AWS ECR. Now going back a step further, your images contain your applications. These applications can be written in different types of languages you prefer. In this demo, we'll use Python to make it easy for us. Alright, so let's start off with the basics, setting up an ECS cluster. I'll leave the default name like that, just removing those random letters at the end. For what we need right now, we'll want to minimize spending time managing the infrastructure, so we'll just use Fargate for now. There are other options like AWS Managed EC2 and Self-Managed EC2. To be honest, I have not used the other two, but I'll make another video once I have enough experience with them. Alright, so we'll move forward to the next step. Okay, so clusters created. Alright, so before we make the service, let's go and skip to making a private repository. This way, when we get to the task definition creation, we'll have the images ready. Alright, so ECR repo ready. Let me just grab the URL for that repo so I can use that for tagging my Docker images. Going back to my IDE, I'm going to grab a very simple web app. Again, like I said, I use Python on this one. It's just an app that shows random GIFs whenever you refresh of the page. So let me show you the Docker file that I made to build the image. So I cut this short and built the image already using the ECR repo URL as a tag. And real quick, I will run it to test the image running as a container. Okay, good. So our app is working now. Let's refresh a couple of times. So now we'll do a Docker push. Since I've already used the URL for tagging, it will upload the ECR we created earlier. Alright, so if you get this authorization token expired, we'll need to log in using our access ID, which I have configured earlier using AWS CLI. So let's try it again. So let me just double check the file on the AWS dashboard. There you go. Now that we have our image ready, we can start with creating the service. This will represent our app in our cluster. But actually, it needs a task definition first, so we'll start there. So a task definition is comparable to a Kubernetes pod. It specifies how CPU and memory are assigned and how containers are set up. So containers can include, sidecars. Examples are log collectors like FluentBit and maybe Prometheus, Also, you can have like an envoy proxy for service to service communication. So these task definitions, they're versioned. So any change to it, you'll have a number by it. So new one will just increment the number. That way it's easier for you to pick the one you need when deploying the service. So I'll leave the inputs with their default values, except for the image URL, which we'll need to update using the ECR URL we got earlier. Okay, so that's done. We'll go back to setting up our service. Okay, so right here in the security group is an important part. So this allows you to specify traffic to access the service. For now, we'll let all the traffic in for port 5000. By the way, this is the port our app listens to for requests. I'll also leave the public IP on. Alright, cool. Let's create the service. Alright, so now we have a service with a task definition. Let's find the IP for that specific task. So let me just grab the public IP for that task, because that's how we will access the application online basically. Yeah, there you go. We usually do not use the direct IP access, as every time you create a new task definition, that IP gets changed as well. But for the purpose of getting a proof of concept up and running for a demo, this will be enough. Ideally, you'll want a load balancer to access these services, which we'll address in the next video. So before we move on, let me show you how a change usually works in these types of setups. So say we'll update the GIFs that gets displayed. Mr. Shaya right here. Alright, build. So then push the same tag. So let's double check our repository and make sure we have two images now sitting in it. Okay, now before it gets reflected to our service, we need to force a new deployment. So once that deployment is deployed, we'll get a new IP and pull it up on the browser. There you go. So in terms of next steps, it's about automating this, so that way when you need to make quick updates, it will get pushed up and running on your cluster. So we'll use GitHub workflows, and then we'll try to apply a load balancer as well.